everyone, my name is Natasya Inggrid from Biotechnology 2025, and today I will present about my review paper, which is called The Development of High Sensitivity CRISPR-Cas12 Cas13 Diagnostics Platforms for Early Stage Pathogen Identification. So, why pathogen detection matters? Accurate and timely pathogen detection is essential for disease management, outbreak control, and public health. Early identification allows healthcare systems can respond more proactively, preventing disease spread. There are some conventional methods like culture-based techniques and polymerase chain reaction or PCR, which are the gold standards but have limitations, such as take days or weeks to generate results for culture-based techniques and the need for specialized equipment laboratory for PCR. These limitations become apparent during the COVID-19 pandemic, which emphasized the need for faster, more sensitive diagnostic tools that accessible at the point of care, especially in resource-limited settings. So, what is CRISPR? CRISPR are clustered regularly interspaced short palindromic repeats. Is a key tool derived transforming a prokaryotic adaptive immune system into a high programmable, rapid, and sensitive nucleic acid detection tool. There are some keys for CRISPR systems. Proteins Cas12 and Cas13 are crucial for diagnostics due to their ability to cleave nearby reporter molecules by recognizing target sequences in high accuracies, which produce detectable signals. Second, rapid and sensitive pathogen detection even at low concentrations. And the last one is for promising technology for diagnostics and portable alternative for traditional methods like PCR. So, what are the mechanisms? CRISPR-associated nucleases such as Cas12 or type 5 and Cas13 type 6 have become foundational tools in molecular diagnostics due to their unique collateral cleavage activity, which act as a powerful signal amplification mechanism following target recognition. Cas12 targets double-stranded DNA, which activates and cleaves surrounding single-stranded DNA reporters to produce a detectable fluorescent signal for pathogen presence. While in contrast, Cas13 targets single-stranded RNA and activates collateral cleavage of nearby RNA reporters, utilized in diagnostic platforms like Sherlock for RNA virus detection, while Cas12 platforms is like RPA, LAMP, and MCDA. So, what is the problem statement and the research objective? For the problem statement is low sensitivity during early infection, delayed diagnosis, expensive equipment and skilled operators needed, the need for rapid point-of-care diagnostics, and COVID-19 highlighted urgency for portable testing systems. And the objective from this review paper is to provide a comprehensive and critical analysis of the development of high sensitivity CRISPR-Cas12 Cas13 diagnostic platforms for early stage pathogen identification. So for the methodology from this review paper is, this review paper is based on the literature review, which is in English language. Databases that I used was PubMed, ScienceDirect, and ResearchGate. The articles published between 2016 until 2026, and the final studies analyzed, there were 5 selected articles for this review paper. Moving on for the results. From literature reviews, this table is show about diagnostic platform reviews. Both Cas12 and Cas13 based platform showed exceptional diagnostics performance with detection limits of 1 to 20 copies per reaction, indicating high sensitivity. Examples include Sherlock for RNA detection and various Cas12 systems paired with amplification methods like LAMP and RPA. These findings suggest CRISPR diagnostics can provide rapid, accurate pathogen detection, which make them strong alternatives to conventional PCR, especially for quick results. This table shows the diagnostic platform reviews comparisons. In this table, I choose 4 platforms which is also discussed in this review paper. There are LAMP, MCDA, RPA, and Sherlock. For LAMP, MCDA, and RPA, there are CRISPR-Cas12, so the function is to target DNA. But for Sherlock, which is from the platform's Cas13, which targets RNA. So for the main limitations of LAMP is high efficiency and specificity, and for the application is point of care and rapid pathogen testing. In MCDA, the main limitation is more complex primer design, and the application is detection of low abundance pathogens. In RPA, for the main limitation is very rapid amplification, but the application is portable and field-based diagnostics. In Sherlock, main limitation for Sherlock is limited to RNA targets, but the application is for SARS-CoV-2 and other RNA virus detection. These are the role of isothermal amplification. What is isothermal amplification? Isothermal amplification, it operates at constant temperature, allowing faster amplification without the need for complex thermal cycling equipment. It also enhances signal detection by converting small amounts of nucleic acid into strong detectable signals, enabling high sensitive pathogen detection. So what are the amplification techniques? So there are 3 amplification techniques. There are RPA, LAMP, and MCDA. For RPA, the function is to rapid DNA amplification at temperatures between 37 until 42 degrees Celsius. For LAMP, the function is to use multiple primers to achieve highly specific and efficient amplification. And for MCDA is to employ multiple primer sets to enhance amplification sensitivity and specificity. What are the benefits for isothermal amplification? Is for faster detection, stronger signal generation, ultra high sensitivity, and point of care compatible. CRISPR-based diagnostics have a lot of applications in public health, including the detection of COVID-19, the viral and bacterial pathogen detection such as SARS-CoV-2, and also their portability and compatibility with point-of-care devices, which makes them suitable for use in clinics, field settings, and resource-limited environments. There are also key advantages include rapid results, high sensitivity, high specificity, and the ability to detect pathogens at very low concentrations. These features make CRISPR diagnostics highly promising for early disease detection and outbreak response. So, moving on to limitations and future perspective. CRISPR diagnostics face challenges before widespread implementation, including the need for pre-amplification, the lack of standardized reporting, and potential of target effects that may impact accuracy. And for the future research should aim to develop amplification-free systems, enhance assay standardization, enable multiple pathogen detection, and conduct large-scale clinical validation to improve reliability and accessible for routine clinical use. And for the conclusion, CRISPR-Cas12 and Cas13 diagnostic platforms enhance pathogen detection with high sensitivity, specificity, and rapid results for various infections disease. Their integration with isotomal amplification and detectable signals improves functionally in resource-limited settings. Cas12 targets DNA, while Cas13 targets RNA, showing promise as next-generation diagnostics tools. However, challenges like pre-amplification, reliance, performance variability, and the lack of standardization exist. So, this is the presentation of my review paper. Thank you.